Hi, welcome to the mathscenter.com. In this video, we are going to look at a problem from the Specimen Paper 2020, Paper 3, Pure Maths. Subject code is 9709/03, the CIE exams. Okay, again, Paper 3, yeah? Pure Maths 3. Before we look at the question, please give this video a like and share as much as you can. Please follow me on Facebook and YouTube. For details of the courses that we offer on our website, please visit our website, themathscenter.com. You get all the details there. Okay, also the full solution to this, my full solution to this will be provided as a link so you can look at it at your time. Okay, so I've just written the bare minimum of what we need to solve the problem on the board. Okay, so this question is a relatively easy question, trigonometry. We are given cos x plus 45 minus root 2 sine x is equivalent to r cos x plus alpha. This is not the way it's written. Please read the question on your exam. But when you read it, you'll know this is the way it should be written before you start. Yeah. Okay, let's start. Cos x plus 45 will be cos x cos 45 minus sine x sine 45 minus root 2 sine x. Okay, and that's equivalent to, let me get another pen. Let me just check. Cos A plus B is cos A cos B minus sine A sine B. Great. And then I have a minus root 2 sine x. And then I have r cos x cos alpha minus r sine x sine alpha. Looks good. Yeah. So leave the right side alone. Let's clean up the left hand side. I have 1 over root 2. No, I want to write it as cos 45, right? Is just to remind you, okay, cos 45 is 1 over root 2. I'm going to write it as, never mind, let me just leave it there, yeah? Cos x, excuse me, cos x minus 1 over root 2 sine x minus root 2 sine x. That will be, I'm not disturbing the right hand side, yeah? We'll worry about that later. Okay, let me quickly check. 1 over root 2 cos x, 1 over root 2 sine x, root 2 sine x. I'm going to write root 2 as 1 over root 2 as root 2 over 2. Okay, cos x minus root 2 over 2 sine x minus root 2 sine x. Okay, 1 over root 2 is root 2 over 2, simply because I see a root 2 sitting here so that I can easily handle my maths. Yeah? So I have got root 2 over 2 cos x. Let's say this is minus half, this is minus half, this is minus 1, so it's minus 3 over 2. So I have minus 3 over 2 root 2 sine x. Yeah? Okay? Minus half minus 1 is minus 3 over 2 root 2 sine x. And now we can bring in, what do we have? Let me hold my pen properly. We have got r cos x cos alpha minus r sine x sine alpha. Okay. So now we will equate the coefficients on the left hand side and the right hand side. So we can write, let's see, cos x. So we can write r cos alpha. Okay, r cos alpha is root 2 over 2, and r sine alpha is 3 over 2 root 2. Okay, not hard. Yeah. So let me just check everything. R cos alpha root 2 over 2, r sine alpha is root 3 over 2. Ah, fantastic. So now we don't need all of these things. Okay, now we don't need all of these things. We can now work here. So if you like, we can call this equation 1 and equation 2. So take 2 divided by 1. 2 divided by 1, we are going to get what? Sine alpha over cos alpha. And we will get, that looks good. This is 3x. Okay, 3x divided by x, we will get 3. Okay, so tangent alpha is 3. So we have CAST. I don't think you need this, but now let me just be a bit more professional about this. Okay, Tangent alpha is 3. So if you look up your calculator, I wrote the number down somewhere. Yeah, okay. So alpha you'll get a 71.57 degrees. That's alpha. Okay. So give your answer in terms of degrees because they gave me 45 degrees here. Okay. And R, we need R as well. What is R? R squared will be what? R squared will be 2 over 4 plus 9 over 4 times 2, which will be 2 plus 18, 20 over 4, which will be 5. Therefore, R will be the square root of 5. And we are done. Yeah. So, I think the question says give your answer to a certain number of significant figures or something. So you can write square root 5 as 2.236 or something. Yeah. That's not important for me. Okay. I repeat, write the answer down as they wanted it. Yeah. I think they wanted R in 4 significant figures or something like that. You read the question yourself. Okay. So I have this angle here and this one here. We are done with the first part. We need to solve the second part. That's easy. Yeah. So we can write it as square root 5. Okay. Square root 5 cos x plus what? 71.57 equals to 2. Because this question here, the left-hand side, this equation, excuse me, let me say that again. The left-hand side of this equation is the same as this thing here. So I'm just using the R cos x plus alpha t, and that will be equals to 2. And then, you know, the rest is easy. Okay, it's stored in the box, right? So let's do that here. We have cos x plus 71.57. That will be equals to 2 over square root 5. And now we have CAST. Cos is positive. Okay. And my first angle, let me just do one round here. I'll have a look. I'll tell you more about it in a minute. Okay. So cos is positive. So your reference angle here, okay, your reference angle from your calculator will be, let me just check that. I wrote it down 26.57. Okay. So now you can write, remember this x, right? X is between 0 and 360. So we can write x plus 71.57 equals to, the first angle is 26.57. The second angle is 360 minus 26.57. Don't stop there, yeah? That's the second one. The third one will be what? 360 plus 26.57. Why? Because this number here is big. Okay, this number here is big. So when you clean it up, you will get your answers. You need this angle as well. Yeah. So we're almost done. Just bring the 71.57 to the right hand side. We don't need this. You get a negative number. This one here, you get something like, let me look at my numbers here. You get something like 261.9. Okay. Okay, 261.9. And the other one is when you use a calculator, you'll get 315. Okay, and we are done. So relatively easy problem. Just don't make any careless mistakes. Thank you very much for watching. Please give this video a like and share as much as you can. Follow me on Facebook and YouTube. Visit themathcenter.com for details of lots of interesting courses. And good luck with the exam on Friday. Thank you.